Okay, this for real is the last video of the exam study guide. You are almost done with semester 1 of geometry. Take a moment and celebrate that. So for problems 105 through 116, point D is going to be at 5, -3. And consistently, that is the point that we are going to be doing things to. We're going to be transforming that point. So I'm going to write that a little bit bigger because we're going to have to reference this over and over again. This is the point that I want to do the things to. We want to transform the triangle using the directions below and write the coordinates of D prime. So it says triangle, this is just a point on the triangle. And so we want to write the coordinates of D prime if each of these individual things was happening to it. So what would happen to this point, point D, if you translated it along this vector? Well, remember that the vector tells you a horizontal change and a vertical change. So it tells you, hey, we're going to decrease the x value by 4. We're going to move it to the left 4, but we're going to increase the y value by 5. So what would you do? You would go 5 minus 4 and -3 plus 5. What would the points of D prime be if that was the change we were doing? D prime would be at 1, 2. 1, 2 would be my final point, okay? If that was the change that we were doing, okay? But what if we wanted to take D and instead of doing a translation along that vector, what if we wanted to reflect it over the x-axis? You know what? Let's go ahead and go to number 106. 106, because this is very similar to, this is just instead of being written in vector form, it's written a little bit differently. Translate using this rule. So take the original D and go ahead and add 2 to the x value and subtract 6 from the y value. So that would be 5 plus 2, and then that would be -3 minus 6. What would be the new coordinates of D prime if that was the case? That would be the point 7, -9. So 7, -9 would be D prime if that was the rule I was doing to it. Okay, 107, I put graphs on here just to help you if you need it. A lot of you like to graph instead of memorizing the rules. So if I take the point D and I plot it at 5, -3, 1, 2, 3, 4, 5, 1, 2, 3. If this is D, and I want to reflect it over the x-axis. A lot of you just like having the reference here over the x-axis, thinking through it instead of memorizing it. D prime over the x-axis would be 1, 2, 3 above that line, 1, 2, 3 above that line. So D prime is going to be, instead of -5, 3, it's going to be at +5, 3. D prime is going to be at +5, 3. Okay? So if you don't want to have to memorize that rule, you can always graph it out. Ask me for graph paper on the exam if you would like. Okay, but what if I took D, the original point, and what if I moved it over the y-axis? What's going to change instead? Instead of it being on the right side of this blue line, 1, 2, 3, 4, 5 on the right, it'd be 1, 2, 3, 4, 5 on the left. So that would be at the point over the y-axis. That would be at the point -5, -3. D prime would be at -5, -3 if I moved it from here to over here. Okay, so just thinking through that. When you rotate something 360 degrees, it stays in the exact same spot. It's like a dog doing a full circle. Like when my dog gets the zoomies after he takes a bath, he does a full 360. And so he stays in the same, he winds up back in the same spot. So that would just be at 5, -3. Okay. Reflect over the line y equals 2. So this is where I do like to graph it. Y equals -2 is what it says. So I'm going to go to a graph. 1, 2, 3, 4, 5, 1, 2, 3. This is the point currently D. And D, not D prime. And we want to reflect over the line y equals -2. The y-axis is this one, but that's not the line I'm reflecting over. I'm reflecting over the line that goes through the y-axis. So it's going to arrow through the y-axis. I kind of think of it like a bow and arrow. It's going to go through the y-axis at 2, -2. So here's -2 on the y-axis. So I'm going to do this in pen. This goes through the y-axis at -2. Y equals -2. This has a 0 slope and it goes through the y-axis at 2. So if I reflect over this line, I'm going to count to the line. I'm going to be 1 above the line. D prime is going to be at 5. What was it at before? -3. So that should be at 5, -1. 5, -1 for D prime. Okay, so we're only using those lines if we need it. Reflect over the line x equals 1. So let's do that again. X equals 1. Not the x-axis, but the line that goes through the x-axis. So here's point D. It goes through the x-axis at 1. So it's going through the x-axis at 1. So again, I'm just going to count. This is 1, 2, 3, 4 on the right of the line. So this will be 1, 2, 3, 4 on the left of the line when I flip it over. And when I count up what that should be at, reflecting over the line x equals 1 is going to be at -3, -3 for d prime. Okay, rotation rules. For the rotation rules, I'm going to take that original point, which is at xy. And for rotation of 90, I'm going to flip them, and I'm going to change the first sign after I flip them. So if it was negative, you make it positive. So I'm going to switch them for d prime. That's going to be at -3, 5, and I'm going to make the first one the opposite sign. So that will be at +3, 5. Okay? Rotation of 180 is where you take them, you leave them in the same spot, but you switch both signs. So the first sign changes and the second sign changes. So what is my d prime going to be at? If the OG was at 5, -3, that's going to be at -5, +3. -5, +3. Okay, 270, I always think this starts with a 2, so this is where you switch them. A rotation of 270 is where you switch them, x, y, they change spots, y, x, but you're going to change that second sign this time because this is the one that starts with a 2. So that, for me, is going to be at -3, 5, but I'm going to change that second sign. And so when I do that, that becomes -3, -5 for d prime. -3, -5. Whoops. There we go. Dilate by a factor of 3. That is when you're dilating it, you're making it bigger or smaller. So since this is k is bigger than, when I say k, I just mean the scale factor. Dilation of k. K is scale factor. So that means I'm going to make it 3 times bigger. You take that 5, -3, and you multiply it by 3. You multiply both of those pieces by 3. So times 3 times 3, that is going to be at 15, -9. 15, -9. When you dilate by a scale factor that is smaller than 0, it is going to get smaller. Smaller than 1. Y'all can tell I'm tired. It's going to get smaller, and so you can either multiply by 1/5 or divide everything by 5. So 5, -3, when you multiply everything by 1/5, multiply by 1/5, that is going to be at the point 1, -3/5. Okay? And that is the end. You have made it. This is our last for real video, video 9. Those graphs were only there if you needed them, so you can just cross them out. And I hope you have such a fabulous Christmas break, and I hope you absolutely rock